all here. We're all here. All right, I'm unmuting you all because as long as there isn't some major background. Quick thumbs up if you can hear me. All right, very good. That's awesome. Things seem to be working then. Like I said, I'm going to unmute you. Good to see you all. It's nice to get back to normal, at least in a virtual way. Gas has never been cheaper and there's nowhere to go. How ironic is that, you know? But that's the way it goes, I guess. If you have a protractor and a ruler, that'd be great. If you don't, that's okay, because we don't really use it for a test. We use them, if this was in a normal situation, I'd hand them all out in class and we would use them and we would just do our assignment in class and we wouldn't have to worry about it. So if you have a ruler, just a ruler, that's fine in this circumstance. If you don't have either, you can kind of, I don't know, just, you can make a straight edge, and I'll show you all that. And but I don't want you to worry if you don't have this equipment. We don't, we don't require all this for the test. And tomorrow I'll show you how we managed to do this without it. But for now, at the very least, watch and try to get a sense of what vectors are, is what we're going to try to do today. I'll try to get this microphone out of the way a little bit, and hopefully you can still hear me all right. But I'm going to use the document camera because I'm going to be using some equipment here. So I'm going to share the screen. I'm going to bring this over. Now, this printed out kind of small. I think I have the notes up on the website if you want to take a look, or if you printed them out. This is pretty much right out of your book. So there are places you can go if you can't read this very well. But this is section 8.1 on what we call vectors. And it says many physical quantities such as speed can be completely described by a single real number called a scalar. So if I was going 50 miles per hour, not giving any sort of direction at all, that's just called a scalar. That's one number. This number indicates the magnitude or size of the quantity. A vector is a quantity that has both magnitude and direction. The velocity of a football is a vector that describes both the speed and direction of the ball. Or if I said I was going 50 miles per hour due east, that would be a vector, because it would have magnitude, it would have how fast I'm going, plus it would have direction. And I'm sitting sideways on my desk. My desk is not very big, so if you're wondering why you're seeing the side of my head, that's why. Yeah, can I show you? Here's where, this is kind of what I'm working with right here. All right, state whether each quantity described as a vector quantity or a scalar quantity. A boat traveling 15 miles per hour. Now that's going to be a scalar. This quantity has a magnitude of 15 miles per hour, but no direction. So our answer on this one would be scalar. A hiker walking 25 paces due west. That's going to be a vector because it describes both magnitude, or in this case, 25 paces, and has a direction. This is the tricky one, a person's weight on a bathroom scale. Weight is a vector quantity that is calculated using a person's mass and the downward pull. So that's kind of the key there, due to gravity. So this is actually a vector. Even though it doesn't specifically give a direction, we know if you weigh something, the direction is down. So a car traveling 60 miles per hour, 15 degrees east of south, that is a vector. It gives both magnitude and it gives direction. A parachute is falling straight down at 12.5 miles per hour. That's a vector because we know it's going down. A child pulling a sled with a force of 40 newtons, that'd be a scalar because it gave no sense of direction whatsoever. So a little bit of terminology to start out with: scalar and vector. A vector is a directed line segment. So we could have, here is a vector right here. It has a length, it has magnitude, and it has a direction. Now, if we have this point as A, the beginning point is A and the ending point is B, we can describe this as vector AB. If we label this whole thing A, then we have vector A. Or we could just say A if we know that that's the context of the problem. We're working with vectors, so we can just say vector A. Standard position. Initial point at the origin. Direction of a vector is the directed angle between the vector and the horizontal line that could be used to represent the positive x-axis. Now, what does that mean? If you have a friend down in Houston, Texas, way down here in Houston, Texas, and this person is going 50 miles per hour heading in that direction, and you're in Omaha going the exact same speed in the exact same direction, we don't call those two different vectors. Those are the exact same vector. Vectors do not have location. So we could put both of these, we could represent both these vectors by putting them into what's called standard position, where the tail is set at 0, 0, or the origin. That's why it's saying the origin here. And just do the same length and same direction. So all three of those vectors are the exact same vector. They're not different. This one just happens to be in standard position. And hopefully I've already alluded to this, but magnitude is the length of the vector. Rather than saying length, when we work with vectors, we say magnitude. And the reason is you could label this as 3 feet. And of course that would be length. But this could also represent 5 miles per hour. That's not length anymore. 5 miles per hour is more of a magnitude, but the magnitude of the vector represents that value. So even though we use the length to describe it, it could represent something other than length. So that's why we have a different name for it. All right, next page. Any questions so far? Any questions on this page? Oh, some of you are muted again. Why is that? I don't want you to be muted. Hold on, let me try to fix that. Stop share, unmute all. There it goes. Unmute all. A couple of you still muted. There we go. Now everybody's unmuted. All right, I'm gonna share again. All right, page 1, done. This print is like super small. So I'm gonna try to zoom in a little bit. Zoom in. That's still pretty blurry. I'll try to give you the best I can, the idea of what's going on here. And I'll write out some things also. The direction of a vector can also be given as a bearing. The quadrant bearing is phi. And it's, use that symbol right there. Is a directional measurement between 0 and 90 east of west of the north-south line. The quadrant bearing of vector v shown as 35 degrees east of south or southeast, written south 35 east. So this is south 35 degrees east. So the way I see it, the way I describe it is I kind of read it backwards. I say that this right here, here's the 35 degrees, and it's on the east side of the south pole, let's say. It's on the east side of the south, and that's where you measure the 35 degrees right there. A true bearing is a directional measurement where the angle is measured clockwise from north. So it's not like the unit circle where you measure it from 0 and you go counterclockwise. A true bearing starts at north and you go clockwise, that direction. So that's a true bearing there. So we can describe this vector as, I can barely read that. I think it says, I don't know what it says, 145. It printed so small. Yeah. Anyway, 0 to 5 degrees. 0 to 5 degrees is 25 degrees from true north. So that would be 0, 2, 5, like that. So now we're going to practice this a little bit. And this time, if we were not in isolation, I would hand out the protractors and the rulers, and we would get a great measurement for these. Like I said, if you don't have this equipment, don't worry. We don't really use these for the test. This says use a rule and a protractor to draw an arrow diagram for each coin you described. Include a scale on each diagram. Now this says A is equal to 20 feet per second, and it's at a, geez, I can't even hardly read this. Let's call it 030. So that's a true bearing measurement. So let's say 1 centimeter is equal to 5 feet. I'm going to go with that scale. So I'm going to draw the angle first. Now it goes from north. If this is a true bearing, it goes from north, clockwise. So I'm going to start at 90 degrees up here, and I'm going to go 10, 20, 30 over here. So right at 120 actually. So there's 030, and then if 1 centimeter is 5 feet, I got to draw this 4 centimeters. So 1, 2, 3, 4, like that. So this right here, here's the 030 right there. Any questions on true bearing? This says V is equal to 75 pounds of force at 140 degrees to the horizontal. I think that says 140 degrees to the horizontal, which is now, that's unit circle talk there, unit circle. So we're going to start at 0 this time and use unit circle measurements for the angle. So 140, I think is what it says. It printed so dang small. There's 140 all the way over there. And let's see, 75 pounds. So 1 centimeter is equal to 25 pounds seems reasonable. So 3 centimeters. So line this up. 1, 2, 3 centimeters. So now this to the horizontal, there's the 140 degrees. That's, like I said, that's unit circle measurements. This says X equals 30 miles at a bearing of south 60 degrees west. This is probably the one of the more confusing ones to figure out. But I try to read it backwards. So it's 60 degrees on the west side of south. So if I go to south and I want to be on the west side, that's to the right. So 60 degrees from the South Pole, in other words. Another way to put it, I guess. So put it upside down. Try to line it up best I can. And we're going to go 10, 20, 30, 40, 50, 60 degrees. That's going to put us over there. 30 miles, how about 1 centimeter is equal to 6 miles? Then I'll drop 5 centimeters if I have room. Try to keep this under the camera. 1, 2, 3, 4, 5. Right there. So this, oh, did I go on the east side? Hey there. I know my east-west. I went on the east side. Someone could yell at me before I complete the whole problem. Don't be afraid to do that. Gosh darn it. 10, 20, 30, 40, 50, 60. There's the west side. Line that up. 1, 2, 3, 4, 5. Right there. So this is south 60 degrees west. This one that I actually drew first would be south 60 degrees east. So that'd be the wrong, I put it on the wrong side. So let's say you don't have, a protractor. Let's say all you have is a ruler. This is all I'm looking for. 20 feet per second at a bearing of 0.65. So 1 centimeter is equal to, let's say, 5 feet. This says 20 at 0.65 degrees. Now, if it's a bearing, that's from north. So I need to go 65 degrees. I'm just going to totally guess that where 65 degrees is, somewhere over here, I would imagine. And I need to go 4 centimeters. So this is if all you have is a ruler at your disposal. 1, 2, 3, 4. Then I want you to label it right here, 0.65. As a matter of fact, I want you to label it even if you have all the equipment. Just tell me where the 0.65 is, and that's what it is. Even if it doesn't measure right, that's what it is, if that's what you label it. And I want you to be as close as you can get. Let's see how far off I am. Oh, I was off about 8 degrees. So pretty close, pretty close. 15 miles per hour at a bearing of south 25 degrees east is what it says. So 1 centimeter is equal to 5 miles, let's say. So 25 degrees, let's see if I can put it on the correct side this time. I don't know, let's see. What do I have to draw it? I got to draw it 3 centimeters at 25 degrees. That's going to be about, I don't know, 1, 2, 3. There's 3 centimeters, and I'm calling that right there. I'm calling that the 25 degrees. Now, if that's what I labeled it, that's what it is. It's somewhere, it's got to be somewhere around 25 degrees, and that's all I'm asking for. If you don't have a protractor. 60 pounds of force at 80 degrees to the horizontal. So 80 degrees to the horizontal, let's go 1 centimeter is equal to, how about 10 pounds? That says 60, by the way. This says 80 degrees to the horizontal. So I'm guessing 80 degrees, well, it's very close to 90. It's only 10 degrees off. That's just kind of a sliver. And I got to go 6, 1, 2, 3, 4, 5, 6 centimeters. Like that. And I label this 80 degrees. Once I label it, as long as it's in the neighborhood, that's what it is. So we have a true bearing. That's from north, clockwise. South 25 degrees. I say that's on the east side of south. So you always draw the angle either from the South Pole or the North Pole when it's in this format. So like north 10 degrees east. The degrees is always drawn from either the North Pole or from the South Pole. Never from the east or west. If it says from the horizontal, that's your unit circle stuff. Any questions on that? All right, I got 11 minutes. I spent way too long on that. Oh, we don't have a whole lot left, though. That's good. Not a whole lot to 8-1 in what we're going to cover today. In your operations with vectors, you will need to be familiar with the following vector types. Parallel vectors. They have the same or opposite direction, but not necessarily the same magnitude. So as long as they're going in the same direction or the opposite direction, they're parallel. So A and B are parallel to each other. A and C, A and E, A and F. Those are all parallel. Equivalent vectors have the same magnitude and direction. So in order to be equivalent, they have to have the same magnitude and direction. So let's see, A and C. A and C are equivalent vectors because they're going the same direction with the same magnitude. A and B are not. One's longer. And A and F are not equivalent, and A and E are not equivalent. They're going in opposite directions. Opposite vectors have the same magnitude, but opposite direction. So if you have opposite vectors, like A and F are not opposite because they do not have the same magnitude. Even though they are going in the opposite direction, they're not opposite vectors. Opposite vectors must have the same magnitude and be going in opposite directions. So like A and E are opposite vectors. So a little terminology. I need to fold this up. What am I doing? 3:06. I got 9 minutes. In an orienteering competition, Tia walks north 50 degrees east for 120 feet and then walks 80 feet due east. How far and at what quadrant bearing is Tia from her starting position? Now, if you have the equipment, this is going to be, fairly straightforward. If you don't, do the best you can, look up the answer, and really, we don't get out the protractor and ruler for the tests anyway. We do this much more algebraically, and we'll do that starting next Monday. We'll do this more algebraically. But just do the best you can, look up the answer, and see how close you are. Now, if I'm going to go 50 degrees on the east side of north, that's kind of in this direction, going from left to right and going up. So I'm going to start the journey down at the bottom left-hand side, let's say. So I have room to do this. If I start way over here on the right and I go to the right, I'm going to run off the page. So you got to plan ahead a little bit on these. What should we make? 1 centimeter. What if I go 12? Is 12 centimeters really long? No, it's not too long. 1 centimeter is equal to 10 feet, let's say. 12 is fairly long, but it's not going to run off the page. I need 50 degrees on the east side of north. I'll line up here, 10, 20, 30, 40, 50. Right there, and I need to make this 12 centimeters long. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, I ran it all the way up here. Oh well. I have to go 8 centimeters due east. Do I have 8 centimeters of room left? I think I do. 1, 2, 3, 4, 5, 6, 7, 8. Oh, I just made it. Just made it. Now the answer, let's see, what does it say? How far and at what direction bearing is Tia from her starting position? We call this the resulting vector. So from the very beginning to the very end is the resulting vector right here. Usually label that R for resulting vector. Now I'm going to measure the angle. And what I get is about 10, 20, 30, 40, 50, 60, 67. I'm getting 67 degrees, and that's on the east side of north. There's the direction, and now I got to measure the length, the magnitude. I'm going to do this so I can read it here. I'm looking at 18.6. So 186 by the scale, 186 feet. So if we were, of course, in class, we'd have all the protractors out, we'd have the rulers out, and you'd be playing along, and it'd be great. But we're just trying to give you the idea of what to do. And then, like I said, next Monday, we're going to turn this into more of an algebraic problem than using the equipment. And then finally, I'm only going to do one of these. I don't think I really need to do both. Here's the answer right here. It says, find the resultant of each pair of vectors using either the triangular or parallelogram method. State the magnitude of the resultant to the nearest centimeter and its direction relative to the horizontal. So we need to, I wish I'd have pre-measured this, but I didn't. Let's say this is at, whenever I get a chance, whenever it gives me the option or doesn't say how to measure it, I always use unit circle measurements. I'm going to try to get this as parallel to the lines as I can. And I'm going to say this is 10, 20, 30, 42 degrees. This is 42 degrees. And right at 2 centimeters. This, I'm just going to assume this is going straight north at 1.2 centimeters, 1.2 centimeters. Now, when I add these two together, what I should get is 2.9 centimeters at 61 degrees. So let's give it a try here. I got to start somewhere, say right there. $42. 42 degrees at 2 centimeters. Right there, and then from that one, I'm going to tack on straight north at 1.2. And this is really a lesson in how far off are you? How accurate can you possibly be? So here is the resulting vector right there. I made it a little too long because I want to be able to measure it on the protractor here. Now that's supposed to be at 61 degrees. I'm a little off. If you can see that, I'm probably at 59 degrees. And if this were to be on a test or a quiz, then we wouldn't. That'd be great. I'd give you 100% on this. So what I got was 59 degrees. It's supposed to be 2.9 centimeters. And I'm pretty much dead on there. 2.9. 2.9 centimeters. All right. There we have it. I'm going to stop sharing. And the next time we meet on Wednesday, we're going to be covering 8.2. And we don't use the equipment for that. It's much more mathematical, much more algebraic. Should be, more for you guys to do rather than just sit there and watch me. Any questions for good of the cause? Yeah, go ahead, Anya. I can't hear you. Can anybody hear Anya? Can't hear you. Can you type it in chat? No, not necessary. I took attendance. When you log on, you have all your names there, and I did it at the very beginning, but great question. There is a question up there, and I didn't see it till right now. I'm almost out of time, but let me share it very quickly. The question is, what is 0.65? Hopefully, maybe I've already answered that, but 0.65 would be 65 degrees clockwise from north. So 0.65, 10, 20, 30, 40, 50, 60. Here's 65. Here's 65. And so that right there would be 0.65. Clockwise from north. Any other questions before we head out?
Yeah. Can you hear me?
I can.
Are we still doing like the Ed puzzles, and like are those on your website?
We're still doing the Ed puzzles. They are on my website. I'll be taking grades for those. And so the quick answer is yes.
And then are we doing anything on like our odd days, like our Tuesdays and our Thursdays?
We have it set up right now so that we're not. So if you look at my website, today's assignment and tomorrow's assignment is the exact same assignment. So today's is for you guys, and for the purposes of my classes, tomorrow is just for 6th period, but it's the exact same assignment. So I'm going to do this exact same thing for them tomorrow.
So for the Ed puzzles then, because I don't see it on your website, I would just look it up on edpuzzle.com.
Oh, yeah. There's no Ed puzzle for today.
Okay.
I always do this.
Sorry.
That's okay. I always do this live in class because we have all the equipment.
Okay.
That's probably why you didn't see an Ed puzzle there. So I'll post them. They'll always be up there. And every time you go to my website to look for stuff, I encourage you to refresh the page, because with all this stuff going on, and I think I'm going to be making changes periodically. So you're going to want the most current version of my website. So every time you go on there, hit refresh so that you have the most updated version. Anything else before we take off? That assignment's on my website. I'm always an email away as far as questions are concerned. You can always make a video, post it up on YouTube, send it to me. You can maybe email me videos, whatever you need to do, and I'll try to get back to you as soon as I can. I'll constantly be checking my email throughout this process. Anything else? Have a great day, everybody. Oh, go ahead. Go ahead.
So for your scales, when you give in like 80 feet, can you make your own scale with the centimeters?
You make whatever you want.
Okay.
Yep.
Thank you.
As long as it doesn't run off the page. Don't make 1 centimeter, 1 foot. Anything else? All right, you guys, take care. Good to see y'all. Bye-bye. Have a great day. We'll see you on Wednesday.